Hello everyone, this is Chemical Kinetics problem solving number 2. If you find my YouTube channel, find problem solving number 1 posted previously. This is another set of questions I'm going to solve step by step. Let's see what are the questions. Question number 1. The rate constant of a drug molecule is equal 4.8 times 10 to the negative 4 per second. Calculate the half-life of the drug molecule. In chemical kinetics, there are three types of rate laws. And rate constant units are different for all three types of rate equations. Looking at this given rate constant unit, we need to determine is this rate law is it 0th order, first order or the second order. Per second units given. Per second is for first order rate constant. Then what is the first order half-life equation? T half is equal ln2 divided by k. ln2 is 0.693. The k value is given in the question. It is 4.8 times 10 to the negative 4 per second. So after you solve this, you can see the answer is 1.44 times 10 to the power 3 seconds. Or if you divide this number by 60, you can convert seconds into minutes, 24 minutes. Question number 2. The student was studying the decomposition of the drug molecules with time. And the student plotted the values of drug molecule concentration versus time. And the slope of the line is negative 4.5 times 10 to the negative 4. The question is calculate the rate constant of this reaction. We are plotting the concentration versus time for zeroth order reaction. Zeroth order reaction, concentration on the y-axis, time on the x-axis. Slope of this line is equal negative rate constant. Slope is negative 4.5 times 10 to the negative 4. Negative 4.5 times 10 to the negative 4 is equal negative rate constant. Then you can remove the negative sign in both sides. Rate constant is equal 4.5 times 10 to the negative 4 molar per second. Third question. Consider the following reaction. This is 1 mole of nitrogen react with 3 moles of hydrogen to form 2 moles of ammonia. During the reaction, molecular hydrogen is reacting at the rate of 0.065 molar per second. This is the rate of disappearance of hydrogen. Now the question is, what is the rate of ammonia being formed? And part 2, at what rate is molecular nitrogen is reacting? Let's write the rate expression. Rate expression for this reaction is change in concentration of nitrogen with time is equal to change in concentration of the hydrogen with time or change in concentration of ammonia with time. You can see in this rate expression, the negative sign is added for the reactants, indicating the reactants consumed with time. Positive sign for the products, product concentration increasing. Hydrogen is a reactant here. To indicate the rate of disappearance with time, we use the negative sign. So then hydrogen is reacting at the rate of 0.065. The meaning is change in hydrogen concentration with time is negative 0.065 molar per second. From the rate expression, if you pick hydrogen and ammonia, we can substitute for the hydrogen concentration negative 0.065 and then you can solve this. 2 times 0.065 divided by 3 is positive 0.0433. That is change in concentration of ammonia with time. Part 2. For part 2, we can pick nitrogen and hydrogen. Again, for the hydrogen concentration, we can apply negative 0.065. Then you can see 0.065 divided by 3 is negative 0.0217. This is a negative because nitrogen is a reactant. It is decreasing concentration with time. Question number 4. From the graph below, using the values from the graph, calculate the slope of the line. How we can calculate the slope of this line? You can see the y-axis is 1 over concentration and the x-axis is time in seconds. This line has a positive gradient, positive slope. Let's calculate the slope. Slope is delta y divided by delta x. If you mark any 2 points on the line, we can calculate delta y and the delta x. Slope is equal y2 minus y1 divided by x2 minus x1. Now let's see what are these y2, y1, x2 and x1. After we apply these 4 values, slope is equal y2 minus y1 divided by x2 minus x1. This is plus 0.002. Now part 2. Calculate the concentration of the reactant A at 300 seconds. So time on the x-axis 300. At 300 seconds, if you go to the line and then go towards the y-axis, you can find the y value at 300 seconds. That is 1.3. At 300, the value is 1.3, but the axis is given 1 over A concentration. Then 1 over A concentration is equal 1.3. We need A concentration. Then A concentration is 1 over 1.3, that is 0.769 molar. Last question. From the graph below, calculate the slope of the line. And then part 2 is calculate the activation energy of the reaction. This is based on the Arrhenius equation. Arrhenius equation is ln K is equal ln A minus EA over RT. Rearrange this equation to get the linear equation. This is linear equation. Ln K is equal minus EA over R times 1 over T plus ln A. You can see it is y is equal mx plus c type equation. The y is ln K, x is 1 over T and m is slope. It is negative EA divided by R. Intercept C is ln A. EA is activation energy. R is the universal gas constant 8.314 joules per Kelvin per mole. Now let's calculate the slope of the line. Then slope of the line is equal negative EA over R. Then we can calculate EA activation energy. Slope is delta y divided by delta x. I picked the first point and the last point and then y2 minus y1 divided by x2 minus x1. The answer is negative 1.83 times 10 to the power 4. Here you can see 10 to the negative 3. The common factor has taken out from the x-axis values. So each of these x values you need to multiply by 10 to the negative 3. Slope from this equation is negative EA over R. R value is 8.314. A is equal slope times R value. That is 152 in kilojoules. I hope now you understand how we can graphically pick some information to calculate the activation energy, and in the previous example how we can calculate the slope of the line. Thank you all for watching. If you find this helpful, please subscribe to the channel for more learning.